It is a common understanding that oil and water do not mix, but many operators of lubrication and hydraulic equipment may not be aware of how even a small amount of water contamination could be damaging vital components, such as pumps, gears, and bearings. In the marine industry, water contamination in critical lube and hydraulic systems pose an even greater risk of heavy financial losses and safety hazards. These losses could potentially add up to hundreds of thousands of dollars in premature system repairs and dry dock time. A unique hazard for the marine industry with lube and hydraulic oil contamination is operating in saltwater environments. One major concern is seawater contamination, such as through leaky propeller pitch control seals into propeller pitch hydraulic systems. This can introduce corrosive salts and water contamination into a lube and hydraulic system, posing a significant threat of exacerbated corrosion and premature failure. To address this issue, MSC Filtration Technologies presents the Phoenix Membrane Portable Oil Dehydrator, a simple, compact solution designed to remove free, emulsified, dissolved water, particulates, and precipitated salts from lube and hydraulic oils, including new environmentally friendly PAG and PEG fluids. The Phoenix Membrane Oil Purifier stands out as a highly effective portable water and particulate removal device, widely acclaimed in the marine industry. Its successful track record includes numerous applications in various systems, such as propeller pitch control hydraulic systems, Z-drives, bow and stern thrusters, steering hydraulic systems, and crane hydraulics. Notable marine users such as Tugboat Companies, the U.S. Coast Guard, and the Australian Navy have all harnessed the exceptional purification performance of the Phoenix. Its portability allows it to fit through hatches and maneuver into tight quarters, while its minimal off-gassing of vapors and fumes distinguishes it from bulkier and more complex oil dehydrators exampled here. The potential for off-gassing of other dehydration technologies could potentially lead to dangerous buildup of noxious or even toxic fumes in sealed compartments, which the Phoenix with its proprietary membrane water removal technology avoids. One final main benefit of the Phoenix Membrane Oil Dehydrator in the marine industry is it is an effective means of removing moisture from new environmentally friendly PAG/EAL fluids, which older shipboard water removal technologies such as expensive water-absorbing filters and centrifuges, the type shown here, no longer work on. The Phoenix operates most effectively with warm oil, with its water removal rate doubling every 20 degrees Fahrenheit as shown here. While some fluids such as Shell PAG, formerly known as Neptune PAG, actually require the oil to be at 110 degrees Fahrenheit or higher in order for effective dehydration and water removal to take place. Because of these factors, there are two ways the Phoenix may be used. The Phoenix may be used as a standalone kidney lube system on lube and hydraulic systems that generate enough heat while running, such as this thruster system, or systems that may not be running but have an internal immersion heater, such as this example of a propeller pitch control hydraulic system. In addition, the Phoenix may also be used in conjunction with a bleed and feed modular inline heater provided by MSC Filtration. This heater is designed to be modular and allows everything to still fit through ship's hatches and into tight quarters. The Phoenix may be used as a kidney loop on any low-pressure oil reservoir with a supply and return connection as shown here, connected to a ship's propeller pitch control system. However, for descriptive purposes, the following examples focus on connecting the Phoenix to a bow thruster's oil supply head tank, so that the oil from the thruster, which is below the waterline, can be recirculated and purified. In this example, the head tank is retrofitted with block valves and hydraulic quick disconnect fittings for easy suction and return hose connections. When the block valving is configured as shown here, oil is now able to flow down into the thruster's gearbox and back up into the head tank, then out to the Phoenix and back down again in a constant loop. If using the Phoenix on the same type of oil as its previous application, such as switching between these two thruster systems, then no oil flushing is required. Move on to the next set of instructions for connecting and startup. However, if using the Phoenix on a new application with a dissimilar and incompatible oil, then follow these steps to prevent cross-contamination. 1. Connect inlet and outlet hoses to the Phoenix as shown. 2. If using hydraulic quick disconnect fittings on the hoses, then temporarily plug opposite quick disconnect fittings into each hose end in order to break flow restriction, as illustrated in the following video. 3. Place the outlet hose end into a bucket. 4. Plug the Phoenix into an appropriate electrical outlet and turn it on. Air should now be pulled into the suction hose, flushing any oil in the Phoenix and the hoses out into the bucket. 5. If no oil comes out of the outlet hose after 20 seconds, then turn the Phoenix off, or wait for all the oil to drain out and then turn off. 6. Place a bucket under the water-removing membrane housing drain valve as shown and open. Wait till all oil drains out and then close. 7. Use a strap wrench to remove the spin-on filter and pour any settled oil into the bucket. 8. Reinstall the filter. 9. Flush 3 to 4 gallons of new clean oil, the same type as planned to be used in the next application, through the Phoenix for about 5 minutes to remove any remaining oil. 10. Shut down the Phoenix and it's ready for installation and use. Please note, for long-term storage of over several months, it is recommended to drain and flush all oil using steps 1 through 8 before storage. Connecting and use. With the Phoenix de-energized, connect hydraulic hoses of appropriate length and end fittings to the Phoenix inlet and outlet as shown. Now connect the other end of the Phoenix inlet hose to the head tank connection as shown, and configure the valving as shown. Then connect the other end of the Phoenix outlet hose to the drain on the head tank and configure its valving as shown. Now it's time to energize the Phoenix by plugging it into a 110-volt 15-amp circuit and turning it on. After approximately a minute, check the side-spinning oil flow indicator to ensure that oil is flowing in and out of the head tank. Now inspect the Phoenix gauges to ensure they are reading nominally. The inlet fluid pump gauge shown here should read less than 10 inches of vacuum. The vacuum gauge should read between 24 inches and 27 inches of vacuum. The pressure gauge next to it should read less than 10 psig, while the white filter plugged indicator should be all the way to the left in the green. But if it has started to move towards the red as shown, shut down the Phoenix and follow the filter change procedure to replace the particulate filter. Now it's time to check the vacuum adjustment valve to make sure it is not closed all the way. It should be cracked about 1/4 turn from totally closed to ensure some moisture-removing sweep air is entering the water removal membrane housing. To confirm, you should feel some exhaust air coming out of the vacuum pump exhaust port, while the vacuum gauge is still reading 24 to 27 inches of vacuum. Finally, after a few minutes of operation, check for any hose or fitting leaks. If any leaks are found, shut down the system and tighten or repair as needed. And regularly re-inspect the gauges and check for leaks during the operation of the Phoenix to ensure smooth functioning. Particulate filter change. Follow these steps to conduct a particulate filter replacement while minimizing the risk of oil spillage. When the white filter plug indicator, as shown here, begins to slide into the red zone while the Phoenix purifier is in operation, proceed with the following procedure. First, turn off the Phoenix. Next, disconnect the inlet and outlet hoses. Open the oil sample valve shown here, and then put a bucket under the water removal membrane housing drain valve shown here. Drain all the oil from the membrane housing into the bucket. Next, shut both valves, remove the used filter using a strap wrench, and then install a new one snug tight. Now reconnect the inlet and outlet hoses and start the Phoenix back up. The Phoenix's performance may now be monitored over time using the sample valve on the particulate filter housing shown here to periodically extract an untreated sample of oil for contaminant analysis. Using the Phoenix with the optional portable bleed and feed heater. Important note, read the Phoenix and heater manuals thoroughly before proceeding, and never power up the heater without making sure oil is flowing through it first. Next, make sure you have 2 sets of hydraulic hoses of appropriate length equipped with the appropriate hydraulic quick disconnect fittings on each end as shown, available from MSC Filtration Technologies. Then, ensure that the heater is unplugged, and finally, ensure that the heater's 3-way valve is in the fully horizontal configuration as shown. Connecting the hoses. First, connect the male quick disconnect end of one of the shorter hoses to the female quick disconnect fitting on the heater's outlet side connection as shown. And then the other end of the hose's female quick disconnect fitting to the suction side of the Phoenix as shown. After that, connect the other shorter hose to the 3-way valve side connection of the heater, and its other end to the outlet of the Phoenix as shown. Next, connect one of the longer hoses from the top outlet heater connection to the drain connection on the header tank shown here. And finally, connect the other long hose between the bottom inlet connection on the heater and the outlet connection on the header tank as shown here. Now configure the block valves on the head tank as shown to allow flow to and back from the Phoenix and heater, and you are now ready to energize the system. Phoenix and heater startup. Now that the hoses are connected and all valving configured correctly, and while leaving the heater unplugged, plug the Phoenix into an appropriate 110-volt electrical receptacle and turn it on. After about a minute, check the flow indicator on the side of the Phoenix for oil flow, and if you do not see flow, shut it down and investigate. Next, check the Phoenix vacuum and pressure gauges for correct readings. The inlet oil pump vacuum suction should read less than 10 inches of vacuum. The white particulate filter plugged indicator should be all the way to the left in the green. The water removing vacuum gauge should read between 24 and 27 inches of vacuum, and the pressure gauge should read less than 15 pounds. Now, before continuing, check for any hose or fitting leaks. If any leaks are found, shut down the system and tighten or repair as needed. Now, after ensuring oil flow is flowing out of the Phoenix, plug in and energize the heater. Next, turn the three-way valve on the heater from fully horizontal to the fully vertical position as shown, and read the flow on the flow meter as shown. Now, crack the three-way valve slightly back to the horizontal position until the full flow on the flow meter drops by about 0.1 to 0.2 GPM. Finally, monitor the temperature gauge on the heater after 20 minutes, which should now have increased to between 110 and 120 degrees Fahrenheit if the heater and Phoenix are both running nominally. If the temperature has not increased, you may need to adjust the heater's three-way valve slightly more vertical to reduce the amount of cold oil coming in from the thruster's gearbox. For an easier understanding of how the Phoenix and heater work in unison, here is a two-dimensional flow video to help. As previously shown, the process starts with the heater's three-way valve in the fully horizontal position, and the Phoenix de-energized. Now, after the Phoenix is energized, and with the three-way valve in the fully horizontal position, the Phoenix pulls oil out of the header tank here, through the heater, through the Phoenix, and pumps it back to the three-way valve, where the full oil flow is then diverted back to the header tank in a constant loop. Now, when the heater's three-way valve is turned in the fully vertical position, all the oil flow that was being diverted back to the header tank is now instead sent back to the Phoenix in a constant loop. When the three-way valve is partially turned back towards the horizontal position, a minor quantity of oil is redirected and circulated between the header tank as indicated by the blue arrows. Nevertheless, the predominant portion of the oil continues to follow a continuous loop around the heater and Phoenix. This design ensures that the accumulated heat from the heater remains concentrated precisely where it's most crucial for effective dehydration. Phoenix and heater shutdown and storage. First, power off and unplug the heater, leaving the Phoenix running. Then set the three-way valve on the heater to fully horizontal. and allow the oil to cool down to manageable levels. Once the oil temperature on the heater temperature gauge has reached acceptable levels, then turn off the Phoenix. Next, remove the head tank outlet hose and set the valving as shown. Then install a loose male quick disconnect fitting into the end of the hose to break vacuum, and then turn the Phoenix back on. This will allow all the oil in the system to be pumped back to the head tank as shown. Now, check the spinning sight indicator on the Phoenix for oil flow, and once there is no more oil flowing out of it, shut it down after 10 seconds. Finally, disconnect all hoses and securely store the system for future use. As demonstrated in this video, using the Phoenix is simple and requires minimal operator involvement once connected. Just run it until your oil is as clean and dry as shown in this time lapse. To learn more about the Phoenix and other oil purification equipment offered by MSC Filtration Technologies, please visit us on the web at www.mscfiltertech.com. And thank you for watching.